Hi, very good morning. Today we are going to discuss about the properties of the material. In this video, we are going to discuss about mechanical properties, stress strain diagrams of metallics, ceramics, polymeric materials, models of elasticity and yield strength, tensile strength, toughness, elongation and plastic deformation, thermal properties, heat capacity, thermal conductivity, thermal expansion of materials, environmental degradation and corrosion oxidation of materials, and prevention of materials. So in the above list we are going to see about the mechanical properties in our first slide. Okay, so the mechanical properties, basically in the materials will be having the following properties, while the material having some kind of loads. Okay, it may be a point load, an ideal load, and then any kind of loads. Okay, so that is stiffness, strength, elasticity, plasticity, durability, malleability, hardness, brittleness, creep, formability, and then weldability. Those properties are available in the materials. Okay, it may be metal or non-metal. Okay, so basically mechanical properties. Elasticity: when the material is deformed under the action of external force, it tries to regain its original shape after the removal of that force. Okay, the mechanical property of the material is called elasticity. The body regains its shape completely before that, it's called as a perfectly elastic body. Okay, the plasticity: this inverse elasticity in the material undergoes elastic strain when the external force is applied. This because of plasticity, the helpful forging and pressing industry, and this help us to identify material easy to deform. Okay, and ductility: a material is ductile when it's can drawn into the wire under the action of tensile force. Ductility material, it may have some kind of high degree plasticity, it easily deformed too. Okay, and stiffness, brittleness, it is the lack of ductility. The material cannot be drawn into the wire, but it falls under the action of external force without any significant deformation. Example, we can get a glass and concrete and cast iron and some metal materials. Malleability: the material can be extended in all direction without any rupture. It is called malleability. Okay, you can see the three kind of important on ductility and brittleness, malleability. Ductility, basically it forms once the material having the tensile property. Brittleness, it forms once a material having a low level hardness, it can easily break. Malleability is it's a type of material, it can easily bend when the material load is applied on the top of the material. Okay, so it's having high degree of plasticity, is not even enough the material. Okay, toughness: the material able to absorb the energy without any fracture. It may be considered as the mechanical testing, the impact energy testing machines. Okay, it will come under that process only. Okay, it can used for only absorb the how much energy absorbed by the material when the load is applied on the material. Okay, hardness is the ability of the material to resist the surface abrasion or indentation, like mineral hardness, when the load is applied on the material by using some round diameter ball, and then likely we can say as the any a golden ball, and then stainless steel ball, and then a cast iron ball. Those balls will be having some kind of hardness. So while we apply on the load on that material, it will be having some penetration. Okay, by checking the diameter of the material, we can measure the how much of hardness will be having by the material. Okay, so this is about the stress strain diagram for the ceramics and metals and polymers. You can see the stress strain for the ceramics. It is mutually increasing, while increasing the stress strain both. In metal, it will be having some 3 points, like yield point, ultimate point, breaking point, and then before yield point we can consider as the elasticity and plasticity. And then polymer, it has also like yield and ultimate, and then elasticity and plasticity too. Okay, so basically you know about the stress is a load by area, strain is change in length by gel length. Okay, it should be known those things.